Hello friends, welcome back to my channel Syntax Adda. My name is Ravi Ranjan and this video is the continuation of our last section on singleton pattern. So in order to have one singleton class, let's say this is the singleton class. So what we had some set of rules, right? So the rule was like we should have the private constructor, right? So we should have private constructor. Why? So that any client or other class should not be able to create the object of that singleton class. Then we had other rule like saying we should have static member, right? Static member variable. Okay, so we should have a static member variable or field variable, right? And last was we should have one static method for access. We should have one static method for access, right? So this method will be static, but the access will be public, right? So that outside class, if they want to use this singleton class instance, they can call this static method, right? So these things we already discussed, right? And by using the singleton pattern, we are also making sure that we are always using only one instance of the class, right? And that instance will be accessible at any point of time. So this is called singleton pattern. But and also we saw the example of the same, right? Now let's see. And this was the example, right? So we have the singleton class, right? Where we have the private constructor, one static field, field member, and then one, static method with public access modifier, right? Now think about a situation when the singleton class is being called by threads, right? So multiple threads can call this singleton instance, right? So in that case, there will be break in the singleton pattern. So let's see what I'm trying to say. We'll see this is an example. Okay, so let's create one package here. Okay, or a class will create. Okay, so first we'll create the package com dot syntax adda dot singleton pattern dot, let's say this is for multi-threading, and then I'm going to create one class called singleton. Same, I'm just singleton. Okay, so we can see here in this package, right? We have created one singleton pattern package and then multi-threading, right? Multi-threading package under this source, right? Under this package, we have this singleton class. So we now we will write the singleton class. First, we should have one private, static, and this is should have the data type as singleton, and I'm giving this name as instance, right? Then we'll declare one private constructor, right? Under this constructor, you can have some, you can write some piece of code here as well. Let's say the use case like configuration manager, right? So in that case, you will have some configuration which should be loaded when application loads. Right? In that case, you can provide some configuration here. So let's keep this as simple here. Now we should have one public static method get instance. So and we'll provide the instance from here by checking if instance is equal to null, then we are going to return instance is equal to new singleton, right? And then we are going to return this instance. So this is our singleton class. Now let's check this, or we'll test this in multi-threading environment. So before that, okay, let's write. So we'll create one more class. Let's say this is for performing the task. Okay, and this class will see this is going to implement, let's say, runnable. That's the runnable interface. Okay, so if you see, we need to implement the abstract method which is there inside this runnable. So let's go to this runnable and see we have one abstract method here called run, which accept nothing, right? Which don't take anything as argument, and also it does not return anything. So it is just to perform any task, right? So just implement this one. Yes, we're going to implement this. Click OK. So override, right? So with this, what we are going to do here, we are going to get the instance of singleton. So we'll write singleton dot get instance, and we'll assign this to singleton. Let's say singleton. Okay, and we'll print it out here. So system dot out dot println, and we'll simply print singleton, right? We'll simply print the singleton, and or will some print some message. Let's say message. Okay, and we are going to print this. Okay, now we'll create one new like main method to test this out. Okay, public static void main, right? So let's instantiate the class task. So runnable, and we'll just call it as task, new task, right? So we have instantiated this. Now create two thread. So thread one equal to new thread, and we'll pass task and the thread name. Let's say this is thread one. Okay. Similarly, we'll have the thread two, and we'll pass task and name thread two. Thread two. Okay. And now we'll start both the thread one dot start, thread two dot start. Okay. So both the thread we are starting. Okay. So let's run this and see the output. So when we are running this, we are seeing at this point of time we are getting the same instance. So both the thread are trying to get the instance from the singleton class, right? And both are returning the right now the same object, right? Now we'll rerun this. Still the same. Now see this. When we run this main class couple of times, then we are able to see this singleton pattern, right, is breaking. We are now no longer is getting the same instance of the singleton, right? So here if you see the instance which we are getting here are different. So in the multi-threading environment, right, we will have the problem with the singleton pattern, right? So how we can overcome this? So before that, we'll just improve this code. Okay, so if you'll notice here, we have implemented this runnable interface, right, in this task, right? And in Java 8, there's a concept called functional interface and lambda expression, right, which is nothing but the implementation. It's like lambda expression is the expression, right, where we can implement the anonymous class, right? So let's say this task class which is implementing this runnable. So let's see here, can we write this in a way? Let's say we don't know this task. We are not writing this task class, okay? And we know we have the method, abstract method in runnable that is called, run, right? So if you see this runnable, we have abstract method called run, which is returning nothing, right? Which is void and it's public. So same way, can we write this method run? It is taking no argument, and now we can write the same piece of code which we wrote here, right? So we can just copy paste the same thing here, and let's see if it behave the same way. If it behaves the same way, then we are good. So yeah, there is no problem in writing this way. So now we can delete this class, right? So this class we can delete, right? So this is kind of lambda expression. So we don't know the name of this class, but we are implementing the method present in the runnable, right, anonymously. So we are not having any class, but still we are able to implement this runnable method here itself. So we are able to eliminate the boilerplate code. Okay. So anyway, that's now stick to this topic here. So we have thread one, thread two, which we started, and we saw this singleton pattern is breaking, right? So how we can overcome this kind of issue if we are facing? So it's a simple, right? If this we are able to if in the multi-threading environment, we can since this is the method which we are exposing, right? So by calling this method, we can get the instance of the singleton. So what we can do, we can make this method synchronized, right? So we can write public synchronized, right? So we have made this as public synchronized static singleton get instance. So we have synchronized this one. So let's run this main method and see what's the output now. So we'll run this. So we see both the same instance, again same instance, again same instance, again same instance. So we are seeing every time we run this program, right, we are getting the same instance every time. So if we have any, if we are running this, if we have, written our code by keeping singleton pattern in mind, and we have to also take care whether that singleton class is going to be accessed by multi-thread threaded environment. If it is multi-threaded environment, then there will be break, right? So in order to overcome this one, we can synchronize the, the static method, right, in the singleton class. So we have used the keyword, we have used this keyword synchronized here. Okay, so but still, when we are using the synchronized, so it will, reduce the performance of your application, right? So if we have such kind of, if you don't want to use synchronized, so we have, other way to, get the instance of the singleton class in multi-threaded environment. So as we are using the synchronized keyword here to, solve the singleton pattern break, right, in the multi-threading environment, but using this synchronized keyword here will reduce the performance. So what you can do, there are different ways by which you can prevent break of singleton pattern. So there are, those ways are like, first, double check locking. Okay, the second one is your initialization on demand holder. Third one is initialization on demand holder idiom, right, and using the enum. So these are the ways by which you can use, or you can implement, right, your singleton pattern in multi-threading environment. Okay, so hope you understood the concept, okay, and how this singleton pattern is breaking and how we can fix that, right? If you like this video, please like and share with your friends, and also subscribe my channel for any further notification. Thank you so much.